right, so this week we're going to be taking a look at section 3.1, which is on what we call inverse trig. We'll spend a couple of days looking at 3.1, and then we'll also look at section 4.1. Right, so basically, inverse trig can be used to undo something. Okay? It's used to kind of go backwards. Right? It's kind of like if you had a number and you squared it. What's the opposite of squaring a number? Square root. Okay, so those two things are opposites. Same thing if you add 6 to a number, the opposite is subtract 6. So for most operations in math, there's an option that you can undo or go back to what you started with. Right? So let me show you an example with trig. So I'm going to put my calculator in degrees. And I'm going to take the sine of 30. Sine of 30. And I get a half. Well, I can do the inverse sine of 0.5, or a half. And what do you think will happen when I hit enter? I'm going to get 30. Yeah. So inverse sine takes me back to what I started with. So that's what inverse sine or inverse cosine or inverse tangent does. So the symbol for it, we usually don't write out the entire word inverse sine. Okay? It's this sign with a -1 up higher. Okay? That's how the calculator does it. And that's how you'll most likely see it in most textbooks, including ours. That -1 is not an exponent. Okay, what's a little confusing about that is the place where you would put an exponent. And in fact, if you put any other number there other than a -1, it is an exponent. But when you put a -1, it's just a symbol that means inverse sine. Okay, it's not an exponent. Another way you can see inverse sine written is arc sine. Okay? So it's a little bit older way of writing it, but some books, some places you might still see it. So if you see inverse sine or arc sine, they mean the same thing. Okay? Same with inverse cosine. Again, cosine with a -1 up higher is how we'll normally write it, but you could see arc cosine. And lastly, inverse tangent. You'll see tan with the -1 or arc tangent. Okay, any questions on the symbol or the abbreviation for inverse sine, inverse cosine, or inverse tangent? All right. Now, there's still the other 3 trig functions, like secant, cosecant, and cotangent, and those have inverses as well. We don't really spend as much time looking at those. We might tomorrow a little bit just to show you how to calculate one. But when we get into using this to actually do stuff with triangles and SOHCAHTOA, that kind of stuff on Wednesday, we are not going to use inverse secant, inverse cosecant, or inverse cotangent. All right, so when you type in a number and press inverse sine, okay, like inverse sine of 0.5. Here's another one, inverse sine of 0.9. Right, whenever you type that in, I could keep going with a bunch of different ones. Inverse sine, -0.85. But no matter what you type in, the answer that comes up on the screen, 30, 64, -58, there's a limit to the answers you're going to get. Okay? And for inverse sine, when you type in something for x, you're always going to get an answer between -90 and +90. Or if you're doing it in radians, it's -pi/2 to pi over 2. Now, anyone know why those numbers are used? Why negative 90 to positive 90? I mean, it's 180 apart, but that doesn't really tell us why. All right, well, the easiest way to show you why is with a picture. So first I'm going to show you why you have to get an answer between two numbers. And then specifically why those two. All right, so let's just type some of these in and see what we get. So this one I already did. The sine of 30 is 0.5. Okay, let's do sine 65. Okay, we get I'm just going to round it to 2 decimal places, 0.91. And the sine of 90, give me 1. Okay, and I'll do the last one in a second. All right, so Peter, if the sine of 30 is 0.5, what's the inverse sine of 0.5? 30, yeah. And Haley, same idea. If the sine of 65 is 0.91, what's the inverse sine of 0.91? 65. Yeah, so you just take this number on the left and you look back at the number, take the number on the right, look back at the number on the left when you're doing inverse sine. All right, well, let's do the sine of 150. We get 0.5. So Eric, what's wrong now, or what problem do you think we could run into?
It's the same as the 30.
It's the same as the 30. So if I said to you, what's the inverse sine of 0.5? Well, do you look at this one and go back and say 30? Or do you look at this one and go back and say 150? Which one should you give me? So first of all, this is the reason why we need to limit our answer. Okay? Because for these kind of problems, we only want one answer. Okay? We all want to agree on the same answer. So that's why we're going to limit it to be between two numbers. But why negative 90 to positive 90? Okay? For that, we're going to look at a picture. Okay, so that's a picture of a sine wave. Okay, we're going to study more about the graphs of trig functions next week. But that's if you graph y equals sine x. Okay, that's what it would look like. And what I'm going to do is I'm going to draw a horizontal line like that. Now, if that horizontal line continued forever, and the wave continued forever, Molly, how many times would the horizontal line and the wave cross? Forever, right? They would just keep crossing. And the idea is that everywhere they cross is another answer to an inverse sine problem. Okay? Every single place they cross. So maybe they're crossing at 30, crossing again at 150. It's going to cross again later on. But it's going to keep crossing forever. So technically, I could find another answer that also has the sine with an answer of 0.5. I could do 390. There's another one. Okay, so now I got 390, 150, and 30. All have that answer of 0.5. Okay, but we only want to have one. So what we're going to do is we're going to block part of the sine function. Okay, we're going to focus just on one kind of small section. Let's pretend we focus on the section from 0 to 180. Each mark you see on the x-axis is 90 degrees. Now, if I do it like that, Connor, how many times is the horizontal line hitting that curve now? Just looking at that picture. Well, do you see the curve? You know what I'm talking about with the curve? The line, the curve in blue?
Yeah.
And then the horizontal line in black? How many times do they cross? Twice. Right? They cross 2 times. Here and here. So we still haven't solved the problem because everywhere they cross, that means it's an answer. We don't want 2 answers. We only want 1 answer. All right, so let's try moving this down like that. And let's try putting that one like that. So Irene, how many times does the curve and that black line cross now?
Once.
How about if I move the black line to different spots? Could it ever cross more than once? No. No, it can never, now it can never cross more than once. So that means if we all agree to stay between negative 90 and 90, that line will only cross the curve 1 time, which means you will only get 1 answer. That's the reason why we stay between negative 90 and positive 90. If we didn't, we could get all kinds of answers and nobody would agree on which one is the right one. Right? So that's the one we would go with. Okay. The one that's at 150, it's somewhere over there, it comes back down, but we're going to ignore that answer. Okay. All right, so any question on why we need to stick between 2 numbers, or specifically why we're going to do it between negative 90 and 90? Do you think negative 90 to 90 is the only way to do it? What do you think, Ryan?
No, can't you just like keep it in the range of like 180 degrees?
Yeah, as long as you keep it 180 degrees apart, you might be able to find another section somewhere else, like that, where it only hits 1 time. But we're not going to use that section. Okay, we're going to agree to use negative 90 to 90. Just understand it's not the only section you could use, but it is the one that calculators use. Okay, that's how calculators do it. All right, let me show you a graph of cosine. Okay, so down here, we're going to do kind of the same thing. That's a graph of cosine. You might be like, well, isn't that the same? Not quite. Okay, it's a little, if I just move these so you can see it. Sine and cosine are a little different. Okay, it's almost like one has been shifted left or right of the other. Let's try the same thing. Let's try negative 90 to 90 and see if that would only give us 1 answer. Okay, so here's my line. I'm putting it right there. Remember, we only want the line to cross 1 time. So Emily, does that work? Does it only cross 1 time?
Oh, me, sorry.
Sorry, yeah.
No, crosses twice.
Yeah, it crosses twice. So for cosine, the idea of negative 90 to 90 doesn't work. But as Ryan said, as long as we keep that 180, why don't we just shift everything a little bit and see if we can find an interval that does work. And that's the interval we're going to look at for cosine. Okay, because now, no matter where I drag that horizontal line, or my graph in this case, it's always going to stay to 1 solution. All right. So we were from here to here. So that's 0. And I said each line is 90. So what's that second red line on the right? 180. No. So for inverse cosine, we are always going to get an answer between 0 and 180. If we didn't do it that way, people could find multiple answers, and that's not what we want. We want everyone to just get 1 answer, and we want everyone to get the same answer. Now for inverse tangent, I'm not going to go into the graph right now. That's a little different. But I will tell you it's negative 90 to 90. Okay? And when we study the graphs, we actually don't study tangent. Okay? Being an intro to trig class, that would be something you would cover more in like a full year class. So we'll study sine and cosine, but not tangent. What's the difference between the answer that you get with inverse sine and the answer that you get with inverse tangent? They look similar, but they're not quite the same. Yeah?
In tangent, the first negative, or like the first one is in radians, not degrees.
Can you say that again?
Like negative 90. for
Yeah.
the-
So it could be negative 90 or negative pi over 2. Yeah, either one. What did you say? That's in...
It's just not in degrees.
Oh,
I don't know if it's supposed to be.
thank you. You caught a mistake I made. Yes, yes, so that's true. They should both be in degrees. So other than my mistake, does anybody see something else that's different, Ryan?
For sine, it can be equal to negative 90 and 90. And
Yep.
for tangent, it's either more than negative 90 or less than 90.
Right, it will never actually equal negative 90 or 90 with inverse tangent. Right? So for inverse tangent, you could get an answer like 89.9, but you'll never get 90. With inverse sine, you could. Okay. Okay, so any questions on those three intervals? All right. All right, so just to compare it to what we did last week, I'm going to show you how the questions I asked last week on the test and how I asked this week are similar, but I'm going to be asking kind of flipped around. So this is what you did last week. I gave you an angle, like, or a coordinate, and you found the trig function. So I might have said, what is the tangent of 45? So you would take that, you would figure out the coordinate, and then you would give me the answer for tangent 45. This week, I'm going to tell you the answer to tangent 45. Okay? I'll tell you the answer is 1. You're going to have to work backwards and tell me what's the angle. So it would be 45. Okay? So that's the difference between last week and this week. This week, I'll give you all the answers that I asked you for last week, and you're going to have to give me the angle instead. So the point with inverse trig is to find an angle. That's what inverse trig does. It gives you an angle. So eventually we're going to get to problems like this. And I'll ask you, what are the other two angles in that triangle? Okay, we'll get to that maybe on Wednesday. Okay, but that's eventually where we're going to use this kind of stuff. Okay, so any questions on how this week is similar but different than last week? It's just like I'm flipping the question around. All right, so now how do you know when you can use the table that I just passed out? Okay, this table. If the answer is a multiple of 30 or 45, you will find it on that table. Okay, that's all that's listed. But you might be like, well, wait, so I can use that table if I know the answer is a multiple of 30 or 45. But that's what you're trying to find. You don't know the answer yet. So how do you know whether or not you should use that table? Because you haven't figured out the answer. So my suggestion is look for numbers like we saw last week. Okay, you look for your square root 3 over 2, square root 2 over 2, 1/2, negatives of everything I just said. If you see any numbers like that, okay, written right there, okay, that's the number you're looking at. Then you use your table. Okay, so those two things that I just circled in red, those are called the arguments. It's the thing that you're plugging into inverse sine or inverse cosine. Okay, if you see an argument that doesn't look like that, it's not a square root 3, it's not a root 2, it's not a 1, a negative 1, it's not something like that, you're not going to find the answer in the table. Okay. All right, so let's look at this one. Okay, inverse sine of 1. Okay, does everybody have what's on the left? Okay. So there's my table. And first thing I have to remember is what I'm looking for an answer between. Negative something, positive something. All right, so we're looking for an answer between negative 90 and positive 90. Okay, so the way you do it is go to your sine column and keep going down the column till you find a 1. Okay, so I'm in my sine column. I'm going to go down. I found a 1 right there. Now from there, I'm just going to go across and read off the angle. Now, let me make that a little bigger. If you look at it, there's 2 choices. Well, there's 4 choices. But 2 are in degrees, 2 are in radians. Okay, let's focus on degrees. Should I write down the 90? Or should I write down negative 270? Technically, they're the same angle, but we all have to agree on the same answer. So which one, bless you, which one are we going to agree on? 90. So that would be what you write down. Or you could also write down pi over 2. That's the same angle, just converted to radians. So which one do you write? Well, just look at the question, read the directions, see what they ask for. If they don't specify degrees or radians, I don't care which one you write. Okay, let's try this one. Inverse sine of negative 1. So Victoria, can you tell me how I would use the chart to find that answer? What would I do?
You go down the sine column until you reach negative 1.
Perfect. We're going to go down the sine column till we find negative 1. And did you find it on the front?
I found it on the back.
On the back? Let's keep going. Yep. So now we have 2 choices. We could write 270 or negative 90. Which one would you pick?
Negative 90.
Yeah, we want to pick the negative 90 because, remember, we said we have to be between negative 90 and positive 90. Okay, any questions on that one? All right, let's try inverse sine of 1/2. All right, so Rudy, can you tell me, if you go down the sine column, where do you find 1/2? Yeah, you find it in the row with the 30. Does anybody see it anywhere else? Yeah, Rudy?
Also at 150.
Yeah, it's also in the row with the 150. This is the first time that's happened. Okay. The argument that we're looking for, the 1/2, appears twice. So now if you're just focusing on degrees, you have 4 choices. 30, negative 330, 150 or negative 210. If you take any angle that I just said and use your calculator and press sine, I'll just do the 150. In fact, we already did that earlier. They're all going to give you 1/2. So out of those four, what's the one that we would write down? Which one, Rudy?
30.
Yeah, we're going to write the 30. Okay? You don't want to put the negative 330. You don't want to put the 150. You don't want to put the negative 210. Okay? It's not that they're not answers. They're just not the answer that we are going to use. Any questions on that? Okay, another reason we use negative 90 to 90 is when we get into solving triangles and kind of figuring out, how big those angles are. If you use negative 90 to 90, it automatically works for that kind of problem. If you don't, it doesn't. Okay? So that's another reason why we're using it. Okay, so take like a minute on your own and see if you can figure out those two. Inverse sine root 2 over 2 and inverse sine negative root 3 over 2. Okay, so let's look at inverse sine root 2 over 2. So Alex, or how many times did you find root 2 over 2 in the sine column on our table?
2.
Yeah, what's the first time you found it? At what angle?
45.
Yeah, it's in the row with the 45.
135.
And it's in the row with the 135. So we've got 4 choices. Can you tell me out of 45, negative 315, 135, negative 225, which one are we going to go with?
45.
Yep, 45. How come?
It's between negative 90 and positive 90.
Perfect. It's between negative 90 and positive 90. Okay, and now let's look at the last one. Inverse sine negative root 3 over 2. All right, so Faith, what row did you find negative root 3 over 2 in?
Negative 60.
All right, so if we go along our table, you find it right there. Did you find it in any other row?
No. Oh, wait, no. 240 degrees.
Yep. So a lot of these numbers you're going to see a couple times, and we always want to look for the answer that is between what?
Negative 90 and 90.
Yep, for inverse sine, negative 90 and 90, so we'll go with negative 60. Right. Any questions on that? So that's how you use the table for inverse sine. All right, well, for inverse cosine, it's pretty much the same idea. This time, go to your cosine column, look for that answer. But can someone remind me what we're looking to be between this time? We're not negative 90 to 90 anymore.
0 to 180.
Now we're 0 to 180. Yep. So I'm going to look for 0 in the cosine column. Okay, I find it here. And technically, if I find an answer that works, I can keep looking to find it a second time. But you're only going to have one answer that works. So if you find that answer right away, you don't really have to keep looking to find it again. So Katie, using our table, what would be the inverse cosine of 0?
90.
Yeah, it would be 90. Any questions on that one? All right, let's try inverse cosine negative 1/2. And so Orion, if you go down the cosine column, where do you find negative 1/2?
240
Let's see, so 240, yep.
and 120.
and over at
120.
120. Let's start with the first one you said. Is 240 between 0 and 180?
No.
No. Is negative 120 between 0 and 180? No. So in this case, neither one of those answers work. Let's go to the second answer you said. How about 120? Is that between 0 and 180? Yes. And that's the answer we go with. Okay, 120. Okay, try that one on your own. Okay, see if you can take like 30 seconds and get the inverse cosine negative root 2 over 2. All right, so we'll finish up looking at the inverse cosine of negative root 2 over 2. Mason, what did you get for an answer for inverse cosine negative root 2 over 2?
135 degrees.
Yep. If I go down, I see negative root 2 over 2. 135, he gave me an answer that's between 0 and 180. There's no need to look for the second answer. Okay, it's not going to work. Okay. Questions on that one? Now, Mason, what if they wanted that in radians? What would you put instead?
3 pi over 4.
Yes, 3 pi over 4. Yep. Right, and we've done a lot, so I'm not going to do as many with inverse tangent, but it's the same idea. See if you can figure out those two. Okay, let's take a look at the inverse tangent. So, Robin, if you start with inverse tangent of root 3, what row did you find that one in? All right, let's take a look. 240, yep, I agree with that. So, do you remember what we have to be between for inverse tangent?
Negative 90 and 90.
Back to negative 90 to 90. Is 240 between what you just told me? No. How about negative 120? No. So there's got to be another place here where we would find root 3 that would be between negative 90 and 90. So how about Connor? Do you see the other place where we have root 3 in the tangent column?
It's in 60.
Yep. And would you go with the 60 or the negative 300?
60.
60, good. Okay, so that's that one. And Emily, how about inverse tangent of negative root 3 over 3? Where did you find that one?
I found it at negative 30. Or was it with? Yeah, 330.
Yep, so at negative 30. And is that between negative 90 and 90? Yep, then there's no need to look for the other answer. That is correct. Okay, any questions on that? Okay, so those are the kinds of numbers you want to look for in your argument, and then check your table. If you had an argument like 0.65, well, you can look on your table in the sign column for 0.65, but are you going to find it? No, it's not there. So a number like that, you just have to know that's not on the table, so we're going to use our calculator. Okay, I'll show you on two different calculators because there's different ways to type it in. I'll start with this one, which if you use a scientific calculator, it's going to work just like this one. So on most calculators, you press second and then the sine function. There are some other calculators where you have to go into a different menu to find inverse sine. If you have one like that, I can try to help you, or you can use one of mine. So you type second inverse sine, and then the number, 0.65. Okay, so we get 40.54, and I'm in degrees. Okay, so 40.54 degrees. Now there's two ways to get it in radians. You can either use what we learned in the first week, multiply by pi, divide by 180, and that'll change it to radians. Or just set the calculator to radians and type it in again. Let's write this. Okay, 0.71. Okay, about 0.71 radians. Okay, any question on typing that in, or anybody who tried it on their calculators? Anyone having trouble typing it in? Okay, generally, I find the most confusing one sometimes is the Casio, because they're not sure. They have to go into like a different menu depending on your model. But that's probably the most straightforward way to type it in. This calculator, a little different. And some people have scientific calculators that work like this one. Instead of typing inverse sine and then 0.65, you type it in backwards. 0.65 and then inverse sine. Okay, so you get the same thing, but you have to type it in backwards. Okay, I don't particularly like the way you do it on that one. I like typing it in the way you see it on paper. All right, so let's try that one. Inverse cosine of negative 0.24. So Irene, when you typed that one in, did you use degrees or radians? Degrees. All right, so let's switch to degrees. And what did you get? Okay, so we get, yeah, that's right. So 103 point, we'll say 89. So that's how you type in inverse cosine. And let's try inverse tangent. Okay, so inverse tangent of 34.3. Right, so Victoria, when you type that one in, did you use degrees or radians?
I haven't checked that one in. I was trying to figure out how to do the negative sign without getting syntax error.
Oh, is yours doing, it's like something different? All right, I'll help you with yours after. I'll take a look at it. Anybody that's not getting an error, able to type that one in? Yeah? 88.33. Okay. Any questions on that one? Okay. So, if you look at the calculator, we can do inverse sine, we can do inverse cosine, we can do inverse tangent. Zach, do you see those symbols on there anywhere? Inverse secant, inverse cosecant, or inverse cotangent? Yeah. No. There is no button to type those in directly. You can still use the calculator to do them. You have to do something yourself when you type it in. So let's look at this. Okay, the goal is to get this to be written like one of the buttons that we have, either inverse sine, inverse cosine, or inverse tangent. All right, so I'm going to show you how you can rewrite this, and then once I do that, I think you'll understand how to do inverse cosecant and inverse cotangent without going through it. And a trick I'm going to use that you might not guess at first is I'm going to take the secant of each side of that equation. I'm going to take the secant of all of that and the secant of that. Now, we haven't talked too much about this, but I have to kind of just tell you this step before, but I don't think you can get it without it. Does anybody know what's going to happen with secant and inverse secant being right next to each other like that? They cancel out. Remember we said that inverse trig undoes regular trig, so it cancels out. Okay, and for now, I'm just going to copy the original problem over here because I'm going to show you something after. All right, now, so we have x equals secant y. What trig function from last week is connected with secant if you flip it? Anybody remember what one? The cosine. So if the secant is x, what do you do to change secant into cosine? Or cosine into secant, either way. You find the reciprocal. So the secant is x. What's the reciprocal of x? 1 over x. Okay. So if secant is x, cosine is 1 over. You flip it. And now, I'd like to get rid of cosine from the right-hand side. What function do you think I can use that would cancel out regular cosine? Right? Yeah, what do we call it?
Cosecant.
So I think he's on the right track. Anyone help him out? What do we call the function that would cancel out cosine? About Matt? It's what the whole thing we're doing
Would it
today.
be inverse
Yeah,
cosine?
inverse cosine. Okay, so remember, inverse cosine and regular cosine cancel each other out. So if you take inverse cosine on the left, take inverse cosine on the right, inverse cosine and regular cosine cancel out, and what's left on the right-hand side now? Y. And then on the left, you have inverse cosine of 1 over x. What letter was by itself when we started on the right-hand side? Oh, Rudy? Yeah, what letter was by itself in the very first line of the problem? Y. What letter is by itself now? Y. So if what's in this box is equal to y, and what's in that box is also equal to y, what does that mean about what's in the two boxes? They're the same thing. So what I've done is I've given you a different way to type in inverse secant, but using a button that you have on the calculator. So if you want to know what the inverse secant of x is, you type it in this way. That's how you type it in. So you use inverse cosine, but you have to flip the number that's inside. It's kind of like what we did last week, but it's a little different. Okay? You just flip what's inside. How about, that's secant. Let's do this one. How do you think you would type in inverse cosecant? Yeah, Ashley?
Would it be sin 1 over x, like sin negative 1 over x.
Yep, inverse sine of 1 over x. And again, now you have a button for that. Okay, you can flip on the calculator and you have an inverse sine button. So now you can do inverse cosecant. And let's finish up with inverse cotangent. Matt, how do you think you would type that in? Because we don't have a button for inverse cotangent on the calculator. So what trig function is related to inverse cotangent by flipping? No, not cosine. Anyone help him out? What trig function is related to inverse cotangent by flipping? Yeah. Inverse tangent. And what would you type in? The inverse tangent of 1 over x. So anytime you want to do inverse secant, inverse cosecant, or inverse cotangent, take what you want to find, the inverse secant or whatever it is, flip it, and then use the function that's related. Okay, it's like the reciprocal. Okay. All right, let's try that. Okay, so I want to find the inverse secant of 1.45. So you can try your table. You can look for 1.45 in the secant column, but you're not going to find it. Okay, so you've got to use a calculator. All right, so Alex, how would I rewrite that so that I can type it in on a calculator?
Cosine, inverse cosine.
Yep.
1 over 1.45.
Perfect. So he picked the reciprocal, the one you get when you flip it, and then he took the 1.45 and flipped it. All right, so we've got second inverse cosine of 1 divided by 1.45. Okay, so we get 46 point, if we're going to round to 2 decimal places, 46.40. And remember, every time you find an answer, it's an angle. So put the degree symbol on it, or if you're in radians, do you have to write RAD? Okay, no, you don't have to write it. All right, let's try inverse cosecant of 2.6. Okay, so Cameron, how would I rewrite that one so I can type it in? Okay, that's going to be the argument we type in. And what function are you going to use? Not sine or cosine. Right?
The inverse of sine.
Yes, inverse sine. Okay, technically this part is exact. Now I'm going to round it off. Anybody get an answer when they type that? Yeah.
22.62.
22.62. Okay, I didn't check that one, but hopefully that's good. All right, and we'll finish up with an inverse cotangent. All right, so Peter, first step. Can you just tell me how to rewrite it?
It would be inverse tangent and then 1 over 0.35.
Yep. So first you got to pick the reciprocal function, inverse tangent. And then you have to flip what's inside. Okay, so let's see what we get. So second tangent, 1 divided by 0.35. Okay, so we get 70.71. Okay, so as I said before, the inverse, cotangent, secant, and cosecant, we don't use these three as much. Okay, about all we're going to do with them is what we just did. For the rest of the week, we're pretty much going to forget about those three, because when we're solving triangles or figuring out how big the sides and angles are, using these would make it more complicated. We're going to stick with the ones that we have buttons for. Okay. But any question on how to just do evaluate inverse trig? Okay. All right, so homework tonight, it's on 187. It's 13 to 17, 19, 20. 22 to 31, and 33. Okay, and that's all. Okay, I think from number around 22 on, you need a calculator for all those. The earlier ones are just practice. You can use the chart. Yeah.
Can you help with this calculator real quick?
Yep. So if anyone needs help with their calculator, I'll come around now and I'll take a look at that.